SOHCAHTOA. Some folks will write it this way. I prefer to write it this way. Alright, reason being, and what is this mnemonic device for, right? Mnemonic device, something that helps us remember. This is to help us remember the three trigonometric ratios. One is the sine ratio. The other is the cosine ratio. The other is the tangent ratio. Alright, and when we write these rules or ratios out, we are going to use abbreviations, but as I am a stickler for how we say things, believing that how we say things has a lot to do with how we then learn and understand those things, we're always going to say sine, cosine, and tangent. Okay, so even though it might be written S-I-N and in some context pronounced sin, we're going to say sine. And the first rule is the sine of theta. How do we define the sine of theta? It is the length of the opposite divided by the length of the hypotenuse. All right, S-O-H. S-O-H, that's the first third of SOHCAHTOA. The second ratio, C-O-S, it's abbreviated C-O-S, but we're not saying cos, cos. It is cosine. The cosine of theta is equal to the length of the adjacent leg divided by the hypotenuse. And, right, that's the second third, middle third. And then finally, please don't say tan, but tangent. The tangent of theta is equal to the length of the opposite leg divided by the length of the adjacent leg. Okay, so much like the geometric mean rules that we've studied previously, the special right triangle rules and relationships that we've studied previously, it's all going to come down to your ability to label the picture, know the rules, and then just plug the information from the picture into the rules. All right, I've been preaching that for a little bit now. But essentially, what you're going to do is take a picture of a right triangle. Okay. We've known, and we will forever know, that opposite across from the right angle, that's our hypotenuse. Okay, and in a 30, 60, 90, we said the short leg is across from the 30, the long leg is across from the 60. Well, in this case, if it's triangle ABC, what you're going to have to know is, right, we kind of have to give you a reference angle, I suppose. The hypotenuse is the hypotenuse is the hypotenuse. That is not changing. But if we're focused on angle A, relative to angle A, this is the opposite leg. And this is the adjacent leg. Same triangle, if we're talking about angle B, they switch. Now this is the opposite leg, and this is the adjacent leg. All right, the hypotenuse is the hypotenuse is the hypotenuse, always across from or opposite the right angle. But as far as the adjacent leg is concerned, the opposite leg is concerned, those are relative to the given angle, the given theta. The triangle on the left, we're talking about angle A. The triangle on the right, we're talking about angle B. And you can see how the opposite leg and the adjacent leg, those labels, do switch, again, depending on the angle in question. All right, so today you're going to be working in using this information, SOHCAHTOA, sine of theta equals opposite over hypotenuse, cosine of theta equals adjacent over hypotenuse, tangent of theta equals opposite over adjacent, right? And those are lengths, by the way, right? We're going to be plugging in numbers. We're going to be plugging in lengths for opposite, hypotenuse, opposite, adjacent, okay? And likely just letter names for theta for now to just identify ratios. All right, so working in working in delta math, okay, opposite angle H, right? This is what we're talking about. You know this is, right, the hypotenuse is the hypotenuse is the hypotenuse relative to angle H. Okay, I hope you'll be able to tell me this is the opposite leg and therefore segment LV. In problem number 3, just going out of order, not scrolling, making you dizzy. Okay, we've known, we'll always know that's the hypotenuse, all right, but relative to angle A, which is the adjacent leg, well, this is the opposite leg, and this is the adjacent leg, right? Label the picture. I know that's something we've been working on. It's all different contexts, different labels, but the same sort of process. What is the context? After identifying that context, how do I label the picture? What are the rules? What do I plug in? All right, so the adjacent leg, segment AG. All right, 2, I'm not dealing with the hypotenuse. Right? I mean, come on. Segment opposite angle H, okay, right? They don't give us an angle because we know the hypotenuse is always across from the right angle. Opposite angle H, okay, here's angle H. This is the hypotenuse, right, next to adjacent, across from, opposite. All right, you'll be able to answer that question. GWWG, sure. Same deal, hypotenuse, 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 not going to bore you. Okay, find the value tangent of I, okay? So you'll use SOHCAHTOA and recall that the tangent of theta is equal to opposite over adjacent. Okay, we have to plug into that rule. We're just going to, we know this is the hypotenuse. Relative to angle I, this becomes the opposite. This becomes the adjacent. And we just want to say the tangent of our angle I is equal to, what did we label as opposite? 27 over, what did we label as adjacent? 36, and then you just want to reduce, okay? And I suppose say the tangent of angle I equals, by a factor of 9, 3 over 4. All right, the tangent of angle I is equal to 3/4. Tangent of angle M, all right, that's the angle we're working with. We know this is the hypotenuse relative to angle M, opposite. Therefore, this must be adjacent. We want the tangent of angle M. Once again, that's opposite over adjacent. So the tangent of angle M is equal to, oh no, you're going to have to do some Pythagorean theorem. I know the answer is 9. Using those triples, 9 over 41. All right, so maybe I'll get some practice with the Pythagorean theorem as well, right? I know 9, 40, 41 is a Pythagorean triple. I see 3, 4, 5, 3 times 2, 5 times 2. This must be 4 times 2. This must be 8. All right, little practice with Pythagorean theorem and triples. So hypotenuse relative to angle Y, adjacent, opposite, tangent theta equals opposite over adjacent. So the tangent of theta is Y. That's equal to opposite over adjacent 6. Rewrite, reduce, factor of 2, 4/3. All right, cosine 724/25. There's my hypotenuse relative to angle W, opposite, adjacent, whoa, tangent, cosine W, adjacent over hypotenuse, cosine W equals, adjacent we labeled 24, hypotenuse we labeled 25. There's your final answer. All right, the only one I guess I haven't done a sine one, whoops, sine of angle M. 12, 15, I'm looking for that leg. This is 4 times 3, 5 times 3. This must be 3 times 3 or 9. Relative to angle M. All right, this is definitely the hypotenuse, but relative to angle M, opposite, adjacent. All right, SOHCAHTOA, sine of M is equal to opposite over hypotenuse. So sine of M equals 9 over 15, reduced by a factor of 3. 3/5. All right, so I hope that's enough. We get again, scrolling back to the beginning, just identifying side lengths, some skills there in Delta Math. They'll ask you questions on that. Identifying the hypotenuse, right? Tangent ratios, just ratios. All right, coming up with this fraction in the end. Now, whether it's a tangent problem, cosine problem, I guess, or sine, you're just using SOHCAHTOA. Label the picture, write the rule, plug in, and reduce. That's it. There's tangent. There's C. Don't worry about rounding. All right, just fractions. And that ought to be it. These last ones, draw a picture. QRS, the measure of angle S is 90, so that's the S. I guess Q and R then are interchangeable. RQ, length of segment RQ 65, length of segment SR 16, length of segment QS 63, the value of sine R. So there's R, they want opposite over hypotenuse, right? The sine of theta is equal to opposite over hypotenuse. So the sine of angle R is equal to 63 over 65. Oh man, don't give me that nearest hundredth nonsense. This is all I'd be looking for. All right, we're not ready to pick up the calculator yet. Those of you who are interested in using calculators, we will be doing that soon enough, but you shouldn't need to do that today. If Delta Math for some reason absolutely is expecting a decimal, won't accept a fraction, then of course use the calculators, in your computers or Chromebooks at your disposal. But yeah, that's about it for me.